Hello beautiful people. Today we're going to learn how to prepare proteinosomes. Proteinosomes are a well-established protocell model. They are permeable microcapsules made out of a protein polymer nanoconjugates. They have a molecular weight cutoff that is approximately of 50 kilodalton, and they are produced by using the Pickering emulsion technique. By the end of this video, you will learn how to prepare a Pickering emulsion, how to transfer the proteinosomes from the oil into the water, and how a proteinosome sample, a typical proteinosome sample, look like throughout all the different preparation stages. Okay, the first thing we want to do is to weight the cross-linker. Into a little Eppendorf. Now, the cross-linker is a reactive molecule and is normally stored under argon. That's why the vial here is sealed with paraffin. So first thing you want to do really is to take it out of the freezer and let it thaw completely. Otherwise, when you open it, moisture will recondense inside and deactivate the cross-linker by hydrolysis. So now it's completely thawed. It's safe to remove the parafilm seal. We can open it. And I am going to weight roughly 2 milligrams of cross-linker per proteinosome sample. Now, this depends on the activity of the cross-linker. If you have a very active cross-linker, a freshly open cross-linker batch, you can probably cut this down to 1 milligram per proteinosome sample. These were 2.1 milligrams of cross-linker, and I'm going to write the exact weight here on the Eppendorf. When you're done weighting your cross-linker, first thing you need to do is to put it back in the freezer under argon. In order to do that, you need a little piece of parafilm, and you come here by the fume hood. There's the argon line. You open your vial, open the argon, make sure there is not a very powerful flux of argon, otherwise you will blow away the powder from the vial, so be careful about that. And you're going to just gently blow argon inside the vial for at least 10 seconds. When that is done, right away close the vial, seal it with the parafilm following these scents here. So that then you can properly stick the parafilm to the vial and the cap and seal it completely. Don't forget to close the argon line. And now this one you can put it back in the freezer. So next we're going to actually prepare the Pickering emulsion. So first thing first, we're going to take 30 microliters of the nanoconjugate and we're going to put it inside these 1.75 milliliter screw cap vial. Okay, next we're going to dissolve the PEG cross-linker into 30 microliters of sodium carbonate buffer, 0.1 molar, pH 8.5. Okay, to help this solution now, we're going to use the vortex. So we want to make sure that all the cross-linker completely dissolves and the solution is nice and clear. What we're going to do next is to add the 30 microliters of cross-linker to the 30 microliters of a nanoconjugate in the vial. Now, before adding the oil and making the Pickering emulsion, we want to make sure that the solution is nice and homogeneous, so we will use the vortex again. And now we are ready to add the 2-ethyl 1-hexanol. 1 milliliter. We let it run gently from the vial's wall. At this stage, we can close the vial, and we're gonna shake it hardly for 30 seconds. So this is how a typical Pickering emulsion looks like. The pink color is due to the rhodamine B tagged nanoconjugate. Now this is ready to be incubated for 72 hours in a dark drawer. In this video we can see the typical water in oil microdroplets of a Pickering emulsion. The protein-polymer nanoconjugate are labeled with rhodamine B, that's why they look red. This video was recorded with a 10 per objective, and these proteinosomes are typically roughly 25 micrometers in diameter. So after 72 hours, the cross-linking reaction is done, and we can now take back our sample. Okay, so here is our sample. As you can see, all the proteinosomes sedimented at the bottom of the vial, forming this nice palette of water in oil droplets. Okay, next thing we need to do is to perform dialysis. In order to do that, we're going to use a dialysis bag that has a molecular weight cutoff of 12 to 14 kilodalton. Okay, so we need to cut a little piece of dialysis membrane. A piece of this size will be more than enough. Just make sure you cut it straight so that we don't pierce the membrane there, otherwise the solution will leak out from in the next experiments. So this is our piece of membrane. We're going to put it in this container here, and we're going to now wet it with water. Okay, so this is the membrane, and we're going to fill this container with a little bit of water so that we can wet the membrane. Now the membrane needs to stay in here for at least 5 minutes to get wet. In the meantime, we can prepare the dialysis bath. Dialysis requires 3 steps. The first one will use 70% ethanol in water, and this is what I'm going to prepare right now. Second step, after 3 to 4 hours, will be against 30% ethanol, and after 3 to 4 hours more, we will switch to complete the water and to complete the transfer of the proteinosomes from the oil into the water. So now I have HPLC grade ethanol here, and I'm going to fill a little bit this beaker with it. Okay, these are our 2/3 of ethanol in volume, and I'm going to add 1/3 of volume in water. I'm going to use milky water, and this is it. Next thing we need to do is to open the membrane and clip it on one end. So in order to do this, I'm going to now handle it with the tweezers. So you don't want to touch the body of the membrane because you can end up clogging the pores, so you always need to handle it from the 2 extremities. So now I'm going to open the water, and I'm going to open the membrane and ensure that a lot of water will pass through it. One end, other end, make sure is nicely opened. There we go. At this stage, pull it sideways a little bit. You can pull it sideways a little bit. We're going to flip it. And I'm going to use the tweezers to hold it for a second while I'm opening a dialysis clip, and I'm gonna clip it. Make sure this is nicely closed. Sometimes the clips get a little bit loose, so make sure this is nice and tight. And we're gonna keep it in the water. Now we need to remove the oil from our sample. In order to do this, because the neck of the vial is very thin, we need to use a double tip. So this one, the first 1 milliliter tip, and we're gonna add the 100 microliters tip right here. Make sure everything is nice and tight. Next, we can remove the Supernatant. Let's perform this operation slowly and carefully, because we want the proteinosome palette to remain at the bottom. So pipette carefully. Now we can dissolve the proteinosome palette in 600 microliters of 70% ethanol in water. This is a very tricky step, so drop the ethanol gently from the vial's walls. Now you can close the vial. To dissolve the palette now, you need to gently rotate it until everything dissolves. Don't shake it hardly, otherwise you will break the proteinosomes. They're very fragile at this stage. As you can see, the 70% ethanol solution progressively become more colored. And now all the palette has been dissolved. At this stage we can load the dialysis membrane. Again, we need to use a double tip in order to retrieve our sample. Here is the dialysis. Let's shake away most of the water. Always handle it from the extremity. And now gently and slowly we pipette the proteinosomes into the dialysis bag. At this stage, we just need to close the dialysis. We're gonna gently twist it and pull it on the side like this. At this stage, carefully, we can flip it. Again, keep pulling sideways so the membrane is nice and flat. I'm gonna use the tweezers to hold it now, while I'm applying the second dialysis clip. Also in this case, make sure the clip is nice and tight, otherwise there is the danger that the dialysis bag will open during the dialysis process. Okay, this is how it looks like. We give it a little swirl, and now we can drop it inside our 70% ethanol solution. Last thing to do is to add a nice stir bar and get a nice stirring going. In terms of stirring, you want to see the bag moving in the solvent. Be careful not to have it too fast spinning, otherwise it can hit the stir bar and perhaps it can open. The dialysis bag can open. So we can lower it a little bit. This is too much. This is the speed we're aiming for. We now need to leave it here to dialyze for 3 to 4 hours. This video shows the rhodamine B tagged proteinosomes after transferring 17% ethanol in water. As we can see, after this solution in the 70% ethanol, the proteinosomes retain their size and spherical shape, thanks to the PEG cross-linker that was dissolved in the water phase of the Pickering emulsion. The video was acquired with a 20-pair objective, and these proteinosomes are in average roughly 25 micrometers in diameter. Okay, so 4 hours are now elapsed, and what we need to do is to switch the dialysis liquid for 30% ethanol in water rather than 70% ethanol in water that is right now. So in order to do that, easy way is to just dump down the drain 2/3 of the volume and replace it with milky water here. So roughly here is going to be 2/3. There we go. Again, make sure that you've got a nice stirring. Yeah, it looks like the bag is spinning nicely at a nice rate, and so we can leave it here now for other 4 hours, and then we will complete the transfer into water. Okay, 3 hours have been elapsed now, and we need to transfer the proteinosomes into full water. So I'm going to switch the 30% ethanol in water for just milky water. Okay, now we're going to leave them for overnight here to dialyze against water. But before doing that, let's make sure there is, as usual, a nice stirring and the dialysis bag is moving nicely in the beaker. Again, before leaving, just make sure the system is stable. Now, it's usual that at this stage you might observe the solution inside the bag to become cloudy, but this is going to be okay. Tomorrow morning the dialysis bag will back to be completely clear, and the proteinosomes will be in water. So don't you worry if you see the solution inside becoming cloudy. The proteinosomes have been dialyzed overnight, and now they are ready to be transferred into a small vial. Okay, first thing we want to do is to open the dialysis bag. Being careful not to drop it. And now we can pipette out our proteinosome solution. Again, try to pipette gently to avoid breaking them because they are fragile. Sometimes you require more than a vial, but that will be completely fine. As you can see, the solution after dialysis looks completely clear, and that's how it is supposed to be. This video shows rhodamine B-tagged proteinosomes in water after the completion of the dialysis process. The proteinosomes retain their size and shape, but the sample look more dilute with respect to the video of proteinosomes in 17% ethanol. A proteinosome sample, if needed, can be concentrated by slow sedimentation for overnight or by gentle centrifugation. This video was recorded with a 20x objective. Okay, just a couple of notes before concluding this video. Proteinosomes are a soft material, so when you pipette it, when you transfer it into another vial or a petri dish, don't forget to pipette slowly and very carefully to avoid breaking them. A couple of problems that you could encounter during a typical proteinosome preparation. When you look at the sample through the microscope, you might notice that proteinosomes are clumped, are aggregated. If that's the case, it means that you added too much cross-linker. If that's the case, you just want to reduce the amount of cross-linker you're adding to the water phase. On the other hand, if proteinosomes are not forming, it could be due to two possibilities. The first one is that the cross-linker has lost its activity, so it's not active anymore. Therefore, it is recommended to retry the sample preparation using a new batch of cross-linker. Or it could be that the protein-polymer nanoconjugate decomposed, in which case you should retry the sample preparation with a freshly prepared stock solution of protein-polymer nanoconjugate 8 mg per milliliters. So now you know how to prepare a proteinosome sample and how to transfer them into water by using dialysis. If you have found this video useful, please click the like button below. Thanks for watching and work safely.